Kathmandu University, currently studying Bachelor of Electrical and Electronics Engineering. I'm a Microsoft Launch Student Ambassador. Apart from university and MLSC community, you can also find me playing chess. It is wonderful to have everybody joining us today in this one-day virtual session. Also, I would like to thank Mr. Pradeep Poudel for providing me this opportunity to host this session. This meetup is brought to you by Nepal Cloud Professionals and Nepal Power BI User Group Community. I wish you all a lot of learning from this event. If you have not heard about these groups before, Nepal Cloud Professionals is a group of independent IT developer professionals, solution providers, and industry thought leaders driving new ideas in cloud computing. If you are someone who works on cloud on daily basis, or it is something you are looking for ideas to benefit your IT channel business, this community is for you. And talking about Nepal Power BI user group, it is a group of Power BI users and enthusiasts in Kathmandu, Nepal, Southeast Asia region for discussion and exchange ideas over the latest updates of Power BI and data platform. If you are a beginner really looking to exploring about Power BI, then this community welcomes you to join. Now, without delay, I would like to move on to calling our first session speakers for today. For the first keynote session called Microsoft Plus AI, I would like to call upon Mr. Pradeep Kandel and Ms. Anisha Baidya. Mr. Pradeep Kandel is MVP for Microsoft and Ms. Anisha Baidya is Head of AI at Dogma Group.
So simply put, it's just a chatbot with a face. So I would say, despite the amount of work that is being put into Sophia, she's nowhere close to the level of intelligence that even a 2-year-old can emote. And it's basically trained on, it basically uses speech recognition that has been designed by Alphabet and kind of, so basically it's designed to learn things over time and get smarter. But that's that. So now, sorry, the slides. So defining an AI system in terms of Turing test is really complex because it also involves even like the total Turing test now goes on to involve robotics and a lot of other aspects. But simply put, like the modern approach of how you define artificial intelligence, there are 4 buckets to it. So it could be systems, like a lot of people are working on like these 4 aspects of AI. The first one being to build systems that can actually think like humans. And then there are other set of scientists and philosophers who think that machine intelligence should be something that's just systems that can act like humans. It doesn't have to think like humans, but it can simply act like humans. So the Turing test would fall under the first bracket, where systems are designed to think like humans, versus the modern approach has these 2. But there is also this ideal approach, because like human beings, we're not rational all the time, and it varies, right? So the ideal situation would be when systems can think rationally, not be, there are so many things like in terms of emotions and everything that kind of puts human beings at a disadvantaged situation, and they're not always thinking. That judgment can be cloudy at times. So we're trying to level that up and build systems that can actually think rationally. And then there are another set of scientists who are working on building systems that can act rationally as opposed to thinking rationally. They don't really care how they think, but they're just concerned about the end goal. Since we've been talking about intelligence and all this AI thinking, like there are a lot of questions about singularity and concerns. The first thing being, our AI going to take over the job market, and will there be no jobs for human beings? But people who are actually like not in this field, or kind of away from the field of computing and mathematics, which is probably not today's audience, but there are also concerns like, will AI surpass human intelligence? They've been influenced by these popular media, and like movies like Matrix and also shows like Westworld and Black Mirror to kind of think into the dystopian aspects, like to think about the dystopian society that a futuristic society that would be taken over by AI and the human civilization would be completely wiped out. So we kind of want to go back to that question as to should we actually fear AI and just understand where we're at. So now I think the easiest way to kind of clarify that question to a layman would be dividing AI or describing it in terms of weak and strong AI. So weak AI, also the better description of it, which I prefer, is narrow artificial intelligence. It's basically AI systems that have been trained to perform specific tasks. And most of the AI or all of the AI that surrounds us today falls under this category, be it Apple's Siri or like Amazon's Alexa, IBM Watson, even the autonomous vehicle that Tesla is building, AlphaGo that has bet human in chess. These all fall under weak AI, and basically incorporates strong AI, or the ones that are depicted in movies, is the AI that actually incorporates artificial general intelligence and artificial superintelligence. So AGI, or artificial general intelligence, is basically it's a theoretical form of AI. It's not there yet in this world. I mean, maybe it's in the other dimension if you build into, like, if you believe in multiverses. Oh well. So AGI basically are machines that have the same level of intelligence as human beings do, and they have consciousness and the ability to solve problems, think, learn, and also plan for their future. So the best example for that would be, if you guys have watched Westworld, Dolores. So the AI systems that are there, who have their own consciousness, and I guess, yeah, let's not go into the movie, otherwise I'll just end the talk with the movie's description. So also, like, if you have watched the 90s movie AI, David, that child is also a representation of AGI, because it's comparable to what a human is, and it does the same kind of thinking, clouded by the AGI's judgment could be clouded by irrational thinking, and it's just the same. They operate in the same way as we do. They have moods and things, yeah, emotions. Now, ASI is actually something that is superior to human beings. And this is something that has been portrayed in movies like Terminator. So the Skynet, it's basically an example of ASI that has a level of intelligence that's way superior to what the most intelligent human being possesses. Again, intelligence is a very subjective, so it's not a quantifiable, there's no way to kind of quantify intelligence. It's a subjective, it has a very subjective connotation to it. So coming back to that now, like, we want to, since we have understood that we're still in the phase of weak AI, where they're not at the level of human intelligence. So we kind of want to understand how close are machines to human intelligence. And there's no mathematical definition of intelligence, and I looked for it all over, but I couldn't find one. But trying to keep this as less subjective as we can, I found this definition that was given by Brandon Rohr, who is a data scientist at Facebook and data robots. So he, in his talk called Getting Closer to Human Intelligence Through Robots, he basically defined intelligence in terms as a function of generality and performance. So now it's basically a function of how much can we do something, and how well can we do that something. So basically, how many different things can we do? So coming back to the same example of my nephew, he could do a wide range of things like mopping, and even can do sit-ups, play chess. Not that he can do it very well, but he can do all those things, versus the other robot that I showed that was being built in the Tokyo University. It had a lot of limitations, and it could only do certain tasks. Now, let's go on to kind of say if we were to plot this in a graph, and this is the scale is in log. So let's not get into the details, but just understand. So if human intelligence, the smartest human or the most well, intelligent human, say if, I mean, we can't really say who's the most intelligent human, but say if arbitrarily they fall here in terms of generality. So, and in terms of performance, the highest value it lies here. Then the area under this graph, or under the area of this rectangle, actually represents human intelligence. Again, this is not a mathematical, like it's just I'm just putting this up to make the explanation clear. And if you want to learn more about this, you can visit that talk given by Brandon Rohr. He does a perfect job in explaining all of these. So if this is human intelligence, then now let's get on to how like various machines can be quantified, machine intelligence. So some machines, they can perform a wide range of tasks that maybe like can even be more than like what a human can do, what an average human can do. So in terms of generality, they fall under here. They kind of go above what a human generality is. But they are limited in terms of performance. So if they can perform a wide range of tasks, then they might not be performing all the tasks very well. So could even fall below a 2-year-old, or but will necessarily definitely fall below what an adult can do. So that's there. And then the other sort of other sort of AI, other sort of machines can actually be very limited in terms of what in terms of the range of tasks they perform, but could do an outstanding job and could even outperform a human being. So I think the easiest example would be AlphaGo. So if we were to look at just a chess tournament, and just an average human intelligence performance would fall way below that of AlphaGo. So that's there. And then since there are so many different machines or different AI softwares, they've all been so we made similar boxes for all of these, and then we came up with this plot. So this is basically the set of all the data sets that have the same amount of area as the rectangle that represents human intelligence. They fall under this curve. Now, if there is a machine that actually falls on this line that exists in today's world, then we can say that they have matched human level of intelligence. But anything below this or to the left of this is, in terms of intelligence, they are beneath human beneath what humans what human intelligence is. But anything that lies above can be categorized as an ASI. So if we look at all the AI, not all, but some of the examples of AI softwares like humanoid robots, self-driving cars, we can see that all of them fall below this curve. Hence, we conclude that we're still in the weak AI phase. Now, I mean, instead of putting history in terms of a timeline, I mean, a lot of people do that as well, but I really like how DARPA kind of categorizes AI's history in terms of various waves of AI. So the first one being first wave of AI, second being second, and third being third wave of AI. And right now we're on the second wave of AI. So let me go into a little bit more depth on what these waves are. The first wave of AI is basically just handcrafted knowledge or rule-based systems that have been designed to perform narrowly defined tasks. So experts basically, they translate their domain knowledge into a set of rules that can actually be interpreted by a computer, and they build a software around that. And an example could be the traditional, I'm not talking about AlphaGo or the series of chess playing software that was built by DeepMind, but just that the game, the chess game that we used to play on our computers, like, I mean, if you're a 90s kid, you would know what I'm referring to. Or even today's, some of the chess playing games that actually doesn't learn from all the opponent's move, or it just it's just a set of rules, and then no matter how many times you play, it just stays, the smartness of that game does not increase, it just stays at that. So that could be one example of a first wave of AI. The other example is TurboTax, which actually so if you just um, it's an accounting software that helps you come up with your tax. So a lot of people in the US, they use this to do the taxes to avoid the huge accounting service charges because it's pretty cheap. And so this was basically like they brought in a set of accountants to kind of define the rules, and then programmers came together to kind of write it as a program. And the software basically, you just need to put in answers to certain fields, and it will calculate how much you owe to the government in terms of federal tax as well as state tax, and also if you owe, if the government actually owes you any refund. Well, but I mean, if the TurboTax system is not necessarily designed to kind of calculate the taxes, because the rules are different in different countries for Nepal, then if you try to go log into this and solve your taxes, then it'll just give you an error. That is because the first wave of AI, they're basically very poor at handling uncertainty and abstracting. They're also very bad at perceiving the outside world, meaning that if you come back to the chess's example, no matter how many times you play, it doesn't learn from it and it's not getting any smarter. But they're very good at logical reasoning over narrowly defined problems because they have been built on a set of rules. So if they give you an answer and if you just do the reverse engineering, you can actually trace back to why that happened. And also the other thing is it's incapable of transferring knowledge to a different problem. Basically, if you just take that, like the same example would be if you just take that tax system to solve the taxes for Dubai or for some other Middle Eastern country, then it would fail unless it has been already predefined to do that. Now, the second wave of AI is basically...
Sorry, just time check here.
Sure.
How long
So,
will it take?
all
Can
right,
you
so I will
conclude in 3
quickly
minutes,
cover
please?
this.
Yeah, thank you.
How much more time do I have, or should I wrap up?
3 more minutes.
All right.
This is
So
fine.
second wave of AI basically is the statistical learning, where you build statistical models and for a predefined task, and then they are trained on big data. So all the deep learning models, AI, NLP systems, speech recognition system, everything falls under this. And so just to be quick, sorry. So these are very good at perceiving things, perceiving the environment and learning from it, because they can recognize one face from the other. And the more data you use, they're good at adapting and very good at learning. But they do not have the reasoning capability. You cannot really, so object recognition system can tell you a cat from a dog, but then if you ask why it's a cat, I mean, unless you want to dig into the mathematical explanation, there's no logical reasoning that a layman can understand. And it's not, also they're very limited in terms of taking on domain knowledge from one, so they're not good at transferring knowledge from one problem to another. So if you have been trained to recognize faces, then if you just bring in a completely different if you bring in an outlier, it doesn't do a great job at identifying that. Hence, we're trying to move on to the third wave of AI, which is basically to AGI. So they should be good at perceiving things, learning, contextual adaptation, and abstracting and reasoning primarily. And they should be some systems that can be trained under minimal data, meaning we're not trying to build robots that can think like what the Western media is portraying, but they should at least be able to tell you why they identify it as a cat. They should be able to go into details like, I said this is a cat because it has whiskers, furs, claws, and because or it could, I mean, the various other features similar to how a child will explain you why it's a cat. And then I would wrap up the session. But if you have any questions, given that we're running really low on time, please feel free to email me at, this is my email, and you can also find me on LinkedIn or even this meetup group. Yeah, that's that. And I would hand it over to Pradeep.
I would hand it over to Srishti. Yeah.
Thank you so much, Mr. Pradeep Kandel and Ms. Anisha Baidya for your remarks. As a reminder to everyone, if you have any queries or suggestion for this event, I would like to request you to mention them in chats. Now, for the second keynote session, without delay, I would like to call upon Ms. Eve Pardi. Ms. Eve Pardi is working as advanced analytics consultant as Avanade, and her keynote session is on responsible AI. Let's welcome her.
Thank you a lot. Welcome everyone to this year's Global AI Bootcamp in the amazing Kathmandu of Nepal. I'm really grateful and very happy that I can be here and that I am invited to this event because I really missed this community. And I'm really excited to share some insights and offer a first glimpse into Microsoft's responsible AI approach, which allows you to build explainable, secure, and powerful AI solutions. Let me quickly introduce myself with a few words. As it's already been said, I am working as an advanced analytics consultant at Avanade, and I'm also a board member of Global AI Community and founder of AI 42. I am also a Microsoft AI MVP, and it was really nice to listen to the previous session because it came to my mind that yes, it is true. People are they have a feeling of fear, and I really hope that during this session you will get an idea of why you shouldn't think about fear. You should think about making people understand how these applications work, how these affect our lives, and how can we use and control them in order to not making people afraid of this. If you have any questions and I don't have time to answer, please feel free to contact me on email, LinkedIn, Facebook, or Twitter. So let's get into this. Nearly 9 in 10 organizations across countries have encountered ethical issues resulting from the use of AI. And we are very much seeing this as a real challenge that customers are facing, as you can see on this recent Capgemini report. And this shows that 9 of 10 executives have reported facing ethical issues in the implementation of AI. And these executives cited reasons, including the pressure to urgently implement AI, the failure to consider ethics when constructing AI systems, and a lack of resources dedicated to ethical AI systems. Since artificial intelligence systems have a growing impact on people's lives on an everyday level, it is fundamental to understand the models, to protect the people, and to control these AI systems. And while machine learning services are constantly developing, Microsoft emphasizes the ethical principles that put people first, meaning that employees are working to ensure that AI develops in such a way that can be benefited in society while warranting people's trust. So the following principles are recognized as cornerstones of a responsible and trustworthy approach of AI, especially as intelligent technology becomes more prevalent in the products and services that we use every day. So first of all, fairness. AI systems should treat everyone fairly and avoid affecting similarly situated groups of people in different ways. For example, excuse me, when AI systems provide guidance on medical treatment, loan applications, or employment, they should make the same recommendations to everyone with similar symptoms, financial circumstances, or professional backgrounds. And many tools, methodologies, and techniques can be leveraged while developing an AI system that treats everyone fairly. And many resources help developers to detect and mitigate biases. For example, FairLearn can turn a classifier that predicts who should be interviewed for a job based on previous hiring decisions into a classifier that predicts who should be interviewed while also respecting demographic parity or other fairness definitions. The next one is reliability and safety. To build trust, it's critical that AI systems operate reliably, safely and consistently under normal circumstances and in unexpected conditions as well. These systems should be able to operate as they were originally designed. It should respond safely to unseen situations and resist harmful manipulation. It's also important to be able to verify that these systems are behaving as intended under an actual operating conditions. So how they behave and the variety of conditions they can handle reliably and safely, it largely reflects the range of situations and circumstances that developers put the model in during design and testing. Because if not maintained properly, AI systems can become unreliable or inaccurate, and that can be especially dangerous in industries where safety may be at risk, like manufacturing and healthcare and so on. And so as an example, data drift monitoring feature in Azure Machine Learning detects changes in the distribution of data that may cause degraded prediction performance. Privacy and security. Oh no, first inclusiveness, sorry. So everyone should benefit from intelligent technology, and inclusive design practices can help system developers understand and address potential barriers in a product environment that could unintentionally exclude people. And AI can improve access to education, government services, employment, and a wide range of other opportunities. And intelligent solutions such as real-time speech-to-text transcription, visual recognition services, and predictive text functionality are already empowering those with hearing, visual, and other impairments. And now privacy and security. So as AI becomes more prevalent, protecting privacy, securing important personal information, and ensuring confidentiality is critical. And as AI systems rely on data to make accurate predictions and decisions, data security issues require close attention. And these require transparency about ingestion, storage, and how consumers would use the data. And techniques like differential privacy, for example, it makes possible to train AI models using private data without sharing it by also identifying data lakes. The people who designed and deploy AI systems must be accountable for how their system operate, which is why we must ensure that these systems are maintained by humans. And it's not just a machine that makes the final decision. You know, who has the final authority that makes a decision that in the end affects people's lives. And this can be done by documenting, for example, the data sets, like what is their key information, their motivation, how it was collected, and what are the recommended uses on the data and so on. And the models and their versions can also be documented. The person who made the changes on them can also be documented. You can use MLOps to make this documentation in place, which makes it easier to track the purpose of the model, where the data comes from to the model, how they were trained, tested, and corrected, and what purposes they are not suitable for. And this also allows you to do reproducible models. Then finally, transparency. When AI systems are used to help making decisions that have tremendous impacts on people's lives, it is critical that people understand how those decisions were made. And a crucial part of transparency is what we refer to as intelligibility, or the useful explanation of the behavior of AI systems and their components. And building explainable AI solutions require the stakeholders as well. For example, from a bank to understand how the loan is given to someone. Because if we figure this out, I mean, the developers figure it out and get a good understanding and get a good review from the stakeholders, we can understand better how these rules function and how are they applied, so that they can identify potential performance issues, safety and privacy concerns, biases, exclusionary practices, or any unintended outcomes. And transparency is key to supporting the other 5 principles, which is why I would like to discuss a tool that can be used to help developers fully understand their models. And furthermore, to increase the understanding of intelligent systems for end users. Thus, users can make better decisions and accept or trust AI solutions. And before going to the demo, let me talk a little bit about this tool actually. InterpretML. This is an excuse me. This is an open source Microsoft toolkit that helps understand and explain model behavior. And this interpretability package can be really useful for any data scientists and business stakeholders as an essential tool for model debugging, for example. Like, why did my model make this mistake? We can use it for detecting fairness issues, whether my model discriminates. For human and AI cooperation, like how can I understand and trust the model's decisions? We can also use it to explain predictions and enable auditing to meet compliance with regulatory compliance, to see whether the model satisfies legal requirements. And it is a good idea to use these tools, not just this, but the others that we will talk about soon, to apply in high-risk applications, for example, in healthcare, finance, or judicial, and so on. And a wide range of explainers and techniques using interactive visuals are great for explaining glass box and black box models as well. Now, let me show you how a glass box model can be explained with this interpretML package. So I'm just going to run over to my demo. And I'd like to start with showing you the data that we're going to work with. So in this data set, we have a sentence and a connected genre. This is going to be our features, and these are our labels. And I also create 2 data sets from this data for the features and the labels. Here you can see all the unique labels, if you want to remember them. And also I returned the example features for each of the labels as well. All right, next I need to create an explainer. This is an object that contains default glassbox classifier and explanation method as well. And then we also have this label encoder of sklearn. This is going to be used for pre-processing. So the data set is prepared here for training and testing. And then we will see that 104,000 features are going for training, and then 26 is going for testing. And then we need to train a model with the use of the fit function, which is part of the explainer that we just created up here. This is going to return the result and the best parameters, and you can see in the pipeline information that we see the preprocessor details. So the preprocessor is part of the explainer as well, the classifier, and then the best parameters. All right, so after training, it is time to score our model. And with the use of the test dataset, the labels now can be predicted. And as a result, we can get back the accuracy, the precision, the recall, the F-score, and it all can be reviewed down here. And here we can see that the results are pretty good. We have like, our machine is like 84% sure about the prediction it makes. But how a model can figure out the genre, like how does it choose the important words from the sentences? This is what we want to figure out. So what we want to do here is to test the model and explain the decision it makes. So now we pull in all the possible labels into the explainer, and then we explain a sentence. And this sentence I chose from the data set we trained the model with, so it's easy for the machine. And I show you, this is the sentence, and what I expect that it should return the proper label, which is the government in our case. So then the explain local function requires the feature as a parameter. that must be categorized. So the model has to figure out the label for the specific sentence. And to see which words are important, the explainer is going to rank these words in this here. And then in the explain local function, I define that I want to see the important words for this specific sentence for the predicted label, which is correctly predicted as government. And then with this code, we return the important words. The first one is the most important one. And here the values, the importance value of the word. This is in the same order with the words and values. But you know, it is really difficult to just understand what's going on here just by looking at numbers. So this is where the visual dashboard comes handy. So here this is an interactive widget that shows whether the specific word moves the decision toward the predicted label. The predicted label shown here, that is the government. And if the feature moves the decision towards the predicted label, these ones are the positive features. These are what we can see here. And the negative ones would move the decision to another label. So in this top of this dashboard, you can see a slider, which allows you to choose how many important words you want to see here. And if you hover over the bars, you can also see the importance values. All right. If you have time later, we can play around with this because I think it's funny. But let me just continue with something even cooler. Because, oh, sorry, that was not what I wanted to do. All right, so one of the key feedbacks received from the community and customers is that while individual tools like interpretML or FairLearn are really useful, it takes a lot of work to wrangle these tools together into meaningful workflows that help to identify, measure, and mitigate errors in models. So over the last year, Microsoft Research has been working on a single pane of glass that brings together all the responsible AI tools in our toolbox. And that pane of glass is called the Responsible AI Dashboard. And at Microsoft Research Summit 2021, this dashboard was already previewed. And on the 7th of December, it has been announced that the Responsible AI Dashboard is now available as open source and on Azure Machine Learning. There's also a new website started that I'm going that brings all the responsible AI tools into one easy to find location. And it supports the following activities. Model assessment or model debugging. This involves understanding how and why AI systems act the way they do, why the model has some issues, and based on this knowledge, targeted steps can be taken to improve the performance. Then we can also look into decision making, which is basically an exploration when estimating the machine learning model's outcome when feature perturbation of a data point would change, and which changes affect this outcome in what way. And this responsible AI dashboard integrates together technologies from several open source toolkits that might be familiar already for you. For example, the error analysis, which identifies cohorts of data with higher error rate than the overall benchmark. And this reveals situations when the model underperforms for specific demographic groups, for example. Then we talked about the interpretML and FairLearn. And this dice is like a counterfactual example analysis. And this shows feature perturbed version of the same data point that would have received a different prediction outcome. For example, a person's loan has been rejected, but and before I'm saying goodbye, let me quickly show you also this web page I was just talking about. And this responsible AI dashboard can be visited responsible.ai where you can already find a lot of information, and you can also try it out. And the cool thing about this tool is I tried it and I already presented this once, that it works on Azure Machine Learning notebooks as soon as the Python 3.8 kernel is fixed. But until that is done, you can go and read about how the tool works. And I would really suggest you to read through this blog post, because this is actually showing you how to set it up and how does it work, what information you get out of it, and so on and so on. And if you want to read more also, the interpret text, hi, can you hear me?
Yes, yes.
How long time ago have you lost me?
Just 2-3 seconds.
Oh, good. Okay, then I just finish up quickly. So what I just wanted to quickly show is that, so next to this responsible AI dashboard, you can read more about the Interpret ML tool as well on Medium. And I can share this link if you want in the chat, so you can read a bit about the Interpret ML's text analysis solutions. And with that, thank you again for having me. And I hope you had some beneficial information out of this session. And thank you again for having me at this bootcamp event, which is really cool to be in Nepal again. And thank you again for Global AI Community for organizing this and for the support from AI 42. Thank you.
Thank you so much.
Please go ahead.
Any questions?
Sorry.
I think Eva has just left. Is he still in the call? Maybe not. So yeah, Srishti, you can take over.
Thank you so much, Ms. Eve Pardi, for your session. Now it's time for some hands-on sessions. I would like to call upon Mr. Marvin Heng for the Boot Composer workshop. Mr. Marvin Heng is MVP for Microsoft. In this hands-on lab, you are going to work with Boot Composer. Make sure to mention your queries in the chat section.
Right, so thank you everyone. So yep, thanks for having me, hosting me over here. So let me share my slide first. Before I'm going through the slides, will you guys mind to do me a favor? Please download this tool, two different tools that are available on the GitHub. So one is actually the Board Framework Composer. Another one would be the emulator. Please have it installed while I'm actually presenting. I hope you guys don't mind. Is that all right?
Just a feedback here, Marvin. So it looks like the hands-on from the participants wouldn't be that easy. So
okay. So don't worry.
Can we just have you going hands-on while the participants join you into your screen? And if they have any questions, we can go a bit slower, right? Add more context to what you are demonstrating. Would be better, I think.
Okay. Yeah, sure.
Yeah.
Just give me a little bit of time. So I will not use the one actually from the Global AI. So I will use one from Microsoft Docs directly. So which is the updated one. Okay. A second. So you guys can download. I think that one will be very quick, right? So it will take a couple of minutes only. So let me paste the link on Microsoft Docs. So while before I'm going through the slides, so you can actually load that tutorial beforehand, so that we can actually speed up a little bit. I understand that probably there are some other presenters behind me, right? So, okay. Just let me know when you can see my screen, yeah? Are you able to see my screen now?
Yeah.
Yes.
Yes.
Okay, cool. Okay. So I'm Marvin. I'm actually a Microsoft MVP in AI category, specific in cognitive services and also bot. Right. So our topic today will be focusing on Microsoft Bot Framework, which is through the Bot Framework Composer and also Bot Framework Emulator. So let me talk about the history, why we would have this bot getting more and more trendy. So first, we used to actually gather together. We meet each other face to face. So I believe over the past few years, Pradeep and many of you actually travel around the world to meet different kind of people and different peoples and attending different events. So you mean we actually have a lot of events, global events happening around the world previously. I mean, physical in person, but today we hardly do it due to the COVID-19, due to the lockdown, due to a lot of restriction, right? So now we are actually apart and to meet virtually. So like today. So I think that is not a bad thing, because we can actually have different speakers from around the world and sharing a lot of knowledge with you guys, and we can learn from each other, right? So, and also we have been paying cash not for everything, but then today we are more or less using digital cash. I believe that will be the similar case in your place also. I believe a lot of governments are actually pushing that, right? Try to avoid getting physical notes. And now we realize that, okay, paying virtually probably is a good way, all right, to replace the physical notes. So it's a similar case when we take orders, we want to order food. I believe nowadays we have we can order food online, we can order using the apps, all these things, right? So that's the question. So when things getting more and more online, so that means we need a lot of more resources, right? So previously, probably you can call the person, hey, I just want to order this in a restaurant, but then today you hardly do that. So now you have to use apps, and who is actually controlling the apps, right? So we need hire a lot of tech geeky guy to handle all the digital orders, but that's not a feasible way. So how many person you can hire, right? So that's why the ways of communication and things being carried out has just changed. You know, WHO also launched their bot, right, to serve all the inquiries about the COVID-19, right? And Microsoft has no exception. They play a big part to actually introduce intelligent services like the bot framework or cognitive services. So we have intelligent cloud and intelligent edge. And Microsoft AI has a lot more comprehensive services available for you guys, especially us like developers, and you guys who can actually explore on this, right? So what is Microsoft Bot Framework? It's actually a comprehensive bot framework to build an enterprise-grade conversation AI, right? So it's available hosted on Azure, and it's definitely scalable and secure, right? And bot framework here, we are also able to actually connect to a lot more services or a lot more features available on the platform. So bot framework can connect to cognitive services, can connect to external third parties like Teams, like Skype, like Telegram, like Facebook Messengers, and many more, right? So without wasting your time, I think I need to actually introduce this Microsoft Bot Framework Composer, which is one of the tools that I actually requested you guys to download beforehand so that we can actually go through the workshop together. So I understand that the time is really limited, and it's really hard for us to actually go, I mean, maybe for me to actually guide you guys go through one by one, but then let's try to catch up as much as possible, right? So yeah, so before I go into workshop, is there any questions? No? Right.
Looks like nothing.
Okay, so I believe you guys have downloaded the Microsoft Bot Composer, and you have this tutorial with you, right? So over here, I will do a couple of things. I will run through a little bit here. So just some of the features or the UI itself of the tools, right? So we have title bar, that is common across all the desktop application. We have menu bar, okay? But the key things here, when we move along this tutorial, we have to understand a few things here. So we have navigation panel, right, at the side here, left side. Then we have Bot Explorer, which is contains probably your dialogue, your bot, and also some of the triggers here, right? Then we are talking about the authoring canvas, which is your conversation flow, right? So we can actually we can see send, response, all these items around here. Then we have properties panel, okay? So we have greeting, I mean, all the properties available here. So you can actually, later on, we will see how it works, okay? Then we have the debug panel, which allows you to actually see what is the problems probably happens in your flow. So maybe things like Louis key is not available, missing, all these things, right? Okay, so as I talked about just now, this part, Bot Explorer. So we have this, it's called, the root here will be your bot, right? This will be your bot. Then what it happens here is this is the dialogue and this is the trigger actions, right? So we will look into that. Okay, so this is the canvas. Okay, so okay, this is a very quick one, just introduction, so that you guys, when we talk about navigation pane, you know where it is. When we talk about authorizing canvas, then you know what it is, right? Okay, so let's go. Are you guys ready? If yes, just type some words in your conversation, in your chat there, so that we can actually I can understand whether you guys are ready or not. Okay. Right. Okay. See, a second, yeah. Okay. Good. So let's open your Bot Framework Composer and click the Create New button. Okay. Right. So okay. Then we name our bot today called Weather Bot. Okay. Let me create a new folder. Sorry. Okay, so we are going to name our bot weather bot. So we will be creating a weather inquiry bot to tell us what is the weather in different places. So in this case, because I'm not familiar in let's see, Nepal country code. Nice. Okay. Right. So it will take a while to actually create the bot. Let's give it a couple of minutes. Okay. So this will be the screen that we will see after we create the bot. Okay. So it will tell us what to do, what you can do with these things. But it's okay. We can ignore it for the time being. Okay. So we are looking at this step now. So hopefully you guys can follow my screen. Yeah. So we are looking at this step now. If you guys can't follow, just let me know. Right. Just unmute yourself and let me know. Okay. So after we create, this will be the navigation pane. This will be the bot explorer. This will be the canvas. This will be the properties panel. Right. So we have few things here: weather bot, greeting, and unknown intent. So let's hit a start on this. We try to run it, and we will see some the bot is actually reacting, right? We just run in the emulator, and this is the screen that we are going to see. It says welcome to bot. Okay, so we are going to go to the next step. So we are going to modify the greeting. So this is called trigger. When you see the lightning icon, this will be the trigger. Okay, so we have a couple things here. If else, all this, welcome to your bot, right? So let's change a response. So just how you see the bot emulator, it says welcome to your bot. So it's sent via this item, this activity. So we were going to change it to. So we are following this. Okay. So welcome to weatherbot and type weather to get started. Okay. So we just restart the bot again. You will see different reaction. Okay, so now let's refresh and you would see welcome to weatherbot and type weather to get started. So now when you type weather, yes, the bot won't recognize any items or meaningful words over here yet. Okay, because we are not actually trained it to be to be so intelligent. So what we will do now is adding a dialogue. Right, so we will go to the bot itself, not the dialogue. This is called dialogue. Yeah, this level is called dialogue. It will be the bot itself. So let's add a dialogue. We call it get weather. So we want to actually tell the bot to get the weather conditions, right? So let's get the weather condition. Okay. So we are creating a get weather dialog. Okay. So what we will do now, we go to the begin dialog and we click here and send response. So we want the bot to ask what to react, right? So we want to actually let it say, let's check the weather. So that when we type weather, and it knows we are actually want to check the weather. So the bot will give a response. Let's check the weather. So then after that, right? So we start a dialog here. Okay, we start a dialog here. Sorry. Okay, we change here. So this is the dialog. Okay, let's change this currently it's using the Louis. This one is Louis, but we want to use the regex for simple design. So we type in regular expression, we choose the regular expression, and we say add a new trigger. So it say intent recognize. So the intent here, I'll explain what is the intent method. So it will be the intention of the user, what the user wants to do, right? So we say whether. Whether. Okay, so we are telling the bot, okay, whenever I type in whether, I should actually prompt the dialog. Okay. So we go to the dialog management and begin a new dialog. Right. So this will be linked to this get weather dialog. So what we are going to expect is when the bot is actually when we open the bot and bot greeting us, then we type in weather, we should actually expect the bot react to us saying let's check the weather. Okay. So now let's restart the bot again. Let's see whether it's actually meeting what we are expecting. Okay, let's restart the conversation. Let's say weather. Okay, so you can see the bot now understand. When I type in weather, it's actually, he actually knows that I want to check the weather, right? Are you guys okay? Can follow, right? So I'll just continue, right? So now we are not only that, other than the bot already know, but we want the bot to ask us question because we want to check the weather at certain locations. So we want the bot to ask us, hey, what is your zip code? What is your postal code, right? Okay, so over here, prompts, let's say prompt me what is your postal code, right? Then go to the user input and say, okay, so we have here. So we want to capture the value of the user input. So after asking the question, we want the bot to capture the value. So we put postal code for the user, right? So at the same time, we want to trim that value because why? Sometimes we may actually key in the spaces, all this. So we want the bot to trim all the invalid spaces, right? Or else sometimes it cannot recognize or it cannot compare. Okay. Right. So now it's okay. Other. So we go to the other. Then now we want to validate the user input. Okay. So if let's say the bot cannot recognize unrecognized prompt, so we will add a message here. Sorry, I do not understand this value. So the value here will be the value from the user input. All right. So please specify 5-digit postal code. Okay. So then after that, we want to make sure the postal code is also a valid format. Okay. So in Malaysia, in Sarawak, the postal code will be 5-digit, 5-number numeric. Okay. So this will be the one. Then invalid prompt. So if let's say more than 5 or less than 5, you would prompt a message saying, sorry, this value is not invalid. It's not valid. I'm looking at 5-digit number as postal code. So this will be the demo purposes, yeah. So if let's say you guys have different digits in Nepal, so you just replace the validation. So over here we have prompt configuration. So we want to set the default value as this. Okay. All right. So let's try to restart again. So we are expecting now when I key in weather, the bot will say, let's check the weather and also asking, what is your postal code? So we want that to happen, right? Okay. Let's restart the board. Okay, so it's saying what is your postal code. Okay, then I can key in. So now we can see that when we key in the postal code, the board doesn't ask us anything. It won't tell anything because we don't have. You remember this flow is stopped here, so it doesn't go to any actions flowing. So it's just stop here and go back to restart the dialog again. So what we want to do is we want to actually pull the data from open weather. So open weather is free services for of course come with the certain limits. If let's say you want paid services, you can actually sign up. Especially some of you actually use do IoT, want to actually change to detect the weather at certain locations. So you can do that, right? So you can sign up. It's actually free for certain criteria. So you can actually call up to 60 calls per minute in the free tier and 1 million calls per month. So that is sufficient for us to actually do developments, right? So, okay. So I'm not going to show you the sign up process because we are in rush, right? Okay. All right. So second. Okay. So let's go to the next one. So get ready with your. Get ready with your board. To copy this key. Oops. Okay, so we are now at this stage. We want the board to actually pull the request from the open weather. So now here, so it says you request the API key. So remember to sign up on open weather if you haven't get a key. So sign up and get follow the prerequisite steps done. Okay, then we can follow this. So I believe you guys haven't signed up, so it's okay. So you can see what I'm doing and try to understand what is the flow here, right? Okay, so what are we going to do? We pull the data from open weather. Okay, so we continue here. So just how we stop here. So now we want the bot to pull data, get the data from open weather. So I have let me go through this URL. So over here it has the token. Then this would be the country code. So I'm from Sarawak, which is under Malaysia. So I put MY. So then the postal user dot postal code. So remember just now we set the user input to user postal code. So this will be the one we are using at here. All right. So we will be using here. Okay. All right. Then after that, we want to make the result property. Okay. So we want to tell the bot, hey, this will be the response from the API. So of course, we have many things. Inside the API response, we have just status code. We have other some other things, some other details, right? Then after that, we will tell the bot this is a response type as JSON. Right. So now what we are going to do? So we will add a conditions here. We will add say if else. So the bot is capable to actually do this also. So if let's say the status code is okay, then we will do something. If not, we will do another thing. So we add a condition here, write an expression, and we delete it. Oops. Write an expression. Right. So delete. So over here we will tell the bot, okay, so this would be the condition. If true, then what are we going to do? So we will set the properties. Set properties, right? Okay. So under here, there will be assignments. So for quick one, let me just copy from the previous. So I explain what is actually happening right here. Sorry, I have to go back and forth because of the time. I need to copy back. Okay, so this would be the assignment. So, right, this assignment is assigning the property value. So because the return value from the API is actually is a JSON file, and of course it's not that understandable by the bot itself. So we have let's see if I have example. Okay, so this would be the example. This will be the sample data, right? So this is how it looks like for the JSON data that returned from the Open API. So we can see there will be a coordination, weather, then it's actually the details of the weather. It will include the icon. It also include some other things, right? Right. So we don't want the bot go and I mean every time pulling the data, we need to actually analyze get like this. So that's why we set it to a simple naming, so called dialog weather, right? So what I will do here, I will add new, okay? But let me, please allow me to copy paste here, right? So we have the dialog weather point to the content, the weather 0, then description, which is the data, right? Just now we have, you can see, okay, so AI response dot content will be this JSON data. So we tell the bot, okay, picking up the data from here, weather 0, right? So because of this is an array, so we pick out the 0, then we get the description. Then similarly, this for the icon, we get from here also. And the dialog city, this will be content name, the name here, right? Then we have the country. Country is over here. Then we have the Kelvin. So the temperature is standard. It's actually specified in the documents of Open API. It's actually in the Kelvin value. So we need to do a conversion. So what you would do here is actually converting it. So Microsoft Board also available to include the mathematics functions. So you can do a conversion, right? So that's it. So let's hide the code again. So see it's actually inputting. Let's continue with the tutorial. Okay, so now we want to actually add a response, right? Send a response. Okay, so over here we will use we will say, okay, the weather in Fahrenheit is this and the Celsius is this, and the weather is what, right? Okay, so this is good to go. And but before that, we want the bot to do something when it is in the false track. Okay, we'll send a response. Okay, we'll say something went wrong. Then we include the API messages. Okay, at the same time, we want to end this dialog. So we did not delete the property. So we are going to delete the user.poster code. Okay. So, all right. So this is the step. We are going to stop here. Oops. Okay. Let me see. Is there any question? I'm there because okay. Okay. So let's try port whether and my postal code. So we will get the data now. So it's actually pulling from the open weather API, right? So 979 Fahrenheit and 26 degrees Celsius, and it is light red. Okay. So just to be sure, okay, just to be sure, I'll put in, right? So it's actually light red, and the weather is here. Okay, good. Right. So now we are basically more or less done for the basic flow. When we ask the bot, when we interact the bot will ask us what is your postal code, and it will get the weather at a specific location. Okay, so now we add the instruction to the conversation flow. So why is it so important to add the instruction to be added to the conversation flow? Because we don't want the bot to be stuck at certain flow and never come out. Okay, so that's why we need to add it. So previously, Microsoft don't have this supported, but today I think they added this, which is you can actually add this cancel flow, standard cancel flow in from the NuGet package, which is very good. I think it's very good. So we can install it here, or you can search, right? You can search Microsoft bot.components.help. And this thing, I think, is very familiar to most of you guys who are using the Visual Studio. It's similarly just like the Visual Studio. You can just add this package, install 1.2, version 1.2. The version might be a little bit different compared to the one in Microsoft. So yeah, let's add, and we hit OK on the README. So now go back to the create. So we will see two different of intent or the dialogue is being added. So one is cancel dialogue, another one is help dialogue. Okay. Okay. So now what it means with the instruction is because let's see whether. Oh, sorry. Let me restart it. Okay. So we stop it. Okay, it's okay. So the reason why is because when maybe we want to do like weather, but suddenly we think of other actions, but we want to cancel that request of the weather. But if let's say you without this instruction, it will forever stuck in the weather loop, and you must complete the action before you can go to the another actions, right? So say for example, like weather. Now I think can cancel, right? Yeah, you see, it will keep asking for the postal code. So help. They just said nothing. City is not found. All this. Okay, so it will forever stuck in the loop. Okay, so we don't want this to be happen. So we want the user to be allowed to actually cancel the action. So we were going to continue with this. Okay, so over here we want this to add a new trigger. We say cancel. Okay, we say cancel, stop, quick, remove. Okay, so this will reject pattern. So we say submit. Okay, let's add another one for help. So since we have the dialog here, the standard dialog here, so we just continue. We say help, support, advice, right? Okay. Okay. So now we have this two different triggers being created. Right, so we want to add a new dialog, begin a new dialog. And we want it to say cancel. Right, then let's go to the another one. We say begin a new dialog too. Okay, begin a new dialog. Right, we say help dialog. Okay, let's go. Okay, before that, let's enable the interruption. So what's available here would be here. Then we add an interruption. Want this prompt for text. We want under here prompt for configuration. Want to add the allow. We want to set this allow interruption. Yes. Okay. Let's now restart the board again. Let's see whether it do the job for the interruption. Okay. Cool. So let's type whether cancel. So now it tells me, are you sure you want to cancel? I say yes. Okay, so you will restart. I'll cancel. So now let's go back to restart again. You say whether I say help. Now it actually tells me I'm a simple board. It sends a response here. So you can add your help flow also. You can further enhance it. But now it's actually sending a simple response. So we have three different responses here. I can help with simple ask. I'm just a basic board for now. Okay, so it does the job. It allows the interruption to go in between. It can cancel the activity or cancel the current flow, right? So now we come to the last part. So this is one of the features of Microsoft Board Framework, which is the cards. So many other board previously does not able to actually do so, doesn't allow the user to do so, like adding a card. Okay, so the card will looks like a bit like Windows 10 tiles like that, something like that. So it will be able to provide some information at a glance. So you don't have to click in, you don't have to do other information steps, but you can straight away just see what is the information available, right? So now you can see this is a very boring kind of message, but we are going to add a card to make it more attractive or interactive. Okay, so now let's get to the get weather. Okay, so we have it here, send a response. Okay, we go to here. Okay, so we are going to replace it with other things. So let's see, get an attachment. So we are going to add a card here and a new. There are several cards here, but we are going to add a thumbnail card to display the icon. Okay, so we have weather, dialog city in the country with the weather and also the postal code and the temperature in Fahrenheit and also the Celsius. And have a nice day. Then we are going to display the icon, right? So this one will be one of it. So let's restart. Sorry, Pradeep, I think I overshoot about 10 minutes. So my time is supposed to reach end at 2:30, right?
Yeah, slightly over the time. But yeah, how long would it take, Baidya, for you?
I think this will be the last step inside the tutorial.
Okay, sure.
Okay, so let's begin. So now you see the card here already. You see weather in Kuching, in Malaysia, the the rain is light rain, and this is the temperature. Have a nice day. Then it have this little bit cute icon on the right hand side. So this will be the thumbnail card of feature of the Microsoft Board framework. All right. So you see the response is being repeated. So it's okay. I think that one is fine. So because we have this. Okay, and here we start again. Right. So this is the basic of the entire board, but we can make it more intelligent with LUIS, so which is the language understanding intelligence systems of Microsoft. It's actually part of the cognitive service also. So in the second part of this tutorial, I would like you guys, I would like you guys to actually explore on your own. If let's say you have any question, you can come to me. So I will share my Twitter, my contact letter. Right, so I restart the board. Okay, let's try again. Okay, so we don't have the duplicated message right there. Okay, that's any questions so far? So this will be the emulator. I believe you guys downloaded the board framework emulator. So this emulator provides a lot of features that you can actually do debugging, all this. You can do debugging here. So see what is the messages, what is the actions on over here. Okay. So I think these two different tools can actually help us. Okay. So we have the second part. I will leave to you guys. So basically, we complete the first part, create the weather board. So this is really simple board using the regex regular expression intent recognition. But we basically complete the over here. We reach here. Then we have the second part, improve the intent recognition with the language understanding. So please have a try, go through this. And I believe this will help you to actually make your board more more capable to recognize different kind of intents. Okay. Right. So do it on your own. And if you have any question, you can come to me. So let's let me wrap up with my session. Okay. So what have you learned and what have we achieved so far? So we actually managed to create the board with Microsoft Board Composer. We know what is the user interface or the controls available on the Composer itself, authorizing canvas, dialog. We have the navigation panel. We have the properties panel. We have the board explorer. We have different items here, dialog, trigger. We have the board itself. And we also learn about the activities, sending response, user input and validation. And we have the if else condition activity. Then we talk about the interruptions. We add the interruptions so that the user won't stuck in the workflow, the conversation flow. If let's say he wants to change mind to actually do other things. Then we talk about the last part, which is the cards itself, right? So that will be the board framework interaction card. Then after that, we talk about, okay, so we create the board using the regular expression intent recognition. Okay, so this is what we achieved in this 30 minutes session. I know it's really express, but yeah. Okay, so what's next for you to explore? So try to improve. You complete the first part first. That would be the very basic board. Then after that, you can continue to work on the second part, which is to improve the intent recognition using the LUIS, right? So what is LUIS? LUIS is actually applies the natural language processing, okay? So it tries to actually understand what human is talking about. So that is the LUIS, okay? So I provide the links here. Don't worry, I will share the slides later on. And the utterance. So there are a couple things inside the LUIS. We got to know, we got to understand what is actually to understand those terminology, right? Utterances is actually an input from the users. It can have many different kinds of inputs. It's not only say whether, help, or cancel. It can means a lot of things. Say, how is the weather? Make it more likely a human, sounds like a human, right? Then it can contain 0 or more entities, right? Then it usually represent on intent. So say weather please. Okay, when you say weather please, then the LUIS will understand you are actually asking for a weather condition. Then I say book a flight to Seattle, then it actually understand that your intentions is actually to book a flight. So intent, so it's actually a categories or the classification of the user intentions, represents an action or the users want to perform. Okay, like book flight, get weather, help, or cancel. Then we have the entities here. So when you say book flight to Seattle, book flight to Singapore, so the Singapore, that term is actually an entity, right? When I say book flight to elsewhere, New York, then that term is actually a city, right? So that will be the entity here. So also the postal code that we just now we talk about, the postal code is actually an entity as well, right? So before ending, so I would like to remind people, you guys again. So all the AI developers should actually be reminded to be responsible, okay, for their AI services or their AI programs, right? So these are actually the Microsoft responsible AI that Eve Pardi has actually shared with us. So you guys can actually recap again, go to Microsoft website to view again responsible AI, right? So it's actually very important. I think it's really other than technical aspect, it's actually about the ethic aspect also, and also the legal aspect. All right. So these will be the references that I will share in a short while, right? So you guys don't have to worry about this. I'll provide the link. So yep. So that's all for my session. This will be the tag for Medium, for Twitter, and also for LinkedIn. So if you guys can actually, if you guys have any questions, just reach out to me, or you want to share some interesting thing with me, so just connect to me. All right, thank you so much. Back to Pradeep and the host. Thank you.
Thank you, Marvin Heng, for the hands-on session on Boat Composer. Feel free to contact him if you have any queries. I guess everyone here has heard about self-driving cars. Well, talking about myself, I am so much fascinated by self-driving cars. Our next session is something about that. For the lightning talk session on autonomous vehicles, I'd like to call upon Ms. Kabita Lama. She is currently working as an analyst at Dogma Group. Let's welcome her.
Hi, can you all see me? Hi, my name is Kabita, and today I'm going to talk about autonomous vehicle. And thank you so much, Global AI Bootcamp, for providing me this platform to present about autonomous vehicle and more. Well, all of us have heard about autonomous vehicle, or maybe self-driving car, or maybe Tesla, Waymo, and so many other self-driving cars. So today I'm going to talk about very simple and very energetic autonomous vehicle. It's going to be very lightning, as mentioned. So my name is Kabita. I'm currently at Dogma with as an AI analyst and more. So let's get into like what is autonomous vehicle. Well, autonomous vehicle is more like a driverless vehicle, or let's say a car or vehicle which can move on its own from one destination to another destination. So like without even human in the loop. So it makes its own decision, but it's in the future. Right now we are in the level 3 in automation vehicle, but more will be done in near future. Okay, so before going into what deep diving into automation, let's see the history. So in history we have the first car. This is all based in US. So we had in 1958 the first car, cruise controlled, was introduced in 1958, and then we had semi-autonomous in 1995, and we had DARPA challenge in 2004, and you have heard a lot from about DARPA from Anisha in previous lecture session. In 2009, Google introduced its self-driving car project, and in 2014 they had a bit of prototype. In 2015, Tesla introduced its autopilot software, and they had it. And in 2016, Tesla gave it in autopilot mode, but it was a bit of an accident. So, but still, Tesla is a growing company. And we have in 2018 to 20, we have massive transit programs, and very numerous states were very much interested in autonomous vehicle. And similarly, in 2011, many companies, many $1 billion of companies have started investing in autonomous vehicle, and in technology and in testing and so on and on. And what makes autonomous vehicle is the label it has defined. We have 6 major label. You can see from level 0 to level 5. So in level 0, there is no automation at all. Like the manual car we have, we start our own engine to looking at the rear view mirror and deciding if to stop or to move, and so on and on. And level 1, we have either to control on speed or steering support. And similarly with level 2, we have partial automation. Level 3, we have situational automation, like you can even like shut your eyes for a minute or for some time. And level 4, you can see like conditional automation, like driver is in like fair condition. And in level 5 is a full automation, where the car takes all the control, where the vehicle takes all the control from reaching from one destination to another destination. And similarly with autonomous vehicle, I have mentioned a small use case of how autonomous vehicle works. We have this car. This car can actually view a lot of things, from traffic recognition to lane to blind spot to rear view to environment mapping, and so on and on. And this is all with the help of long range radar, lidar, camera, short and medium radar, and other like very high resolution cameras and sensors and many things. So whenever we talk about self-driving car, we have this very sexy and luxurious car, Tesla. Tesla is making a very big change and very drastic change in the field of selfless driving car. And this is one of the very luxurious and sexy car, which looks like it will fly very, very soon. And this is so how AI is impacting in the field of autonomous vehicle is very interesting. And so one of the, well, he is the legend himself, the Elon Musk and his Cybertruck. So what are the input sources for autonomous vehicle? So this is the major question, but these are not the only thing, okay? So there are more. This is just a basic. So we have high resolution cameras, we have lidar, radar, GPS, digital map, current speed and acceleration, and many more. So all this helps us to receive input data for our AI, and AI will be able to process all this data into its system, and then it makes it more autonomous vehicle. So we have also a Waymo. Waymo is from Google, which is very in the market, making its way in self-driving car. It's very good, and it has a radar which can detect objects in rain and fog and snow, and it has 360 degree of vision, and it has 3 LiDAR, and many more. We also have Baidu. It's a Chinese company, and this is also doing very well in the business. This is also coming forward as self-driving car and autonomous vehicle. So these are all coming into a market with a very big vision and aim. And similarly, we have Cruise. This is in collaboration with Microsoft. Cruise use Azure cloud computing, and it uses, well, everything, like from radar and everything. And this is more best into cloud computing, Azure. And also Audi. Audi is also into in the market, making its way in the field of autonomous vehicle. This Audi also is in, it has also teamed up with Microsoft and uses an Azure platform. So what are the required features to have an autonomous vehicle? So here we can see a motion planning. This is just a very basic approach for how to decide how to do autonomous vehicle, how to decide how to drive. So Tesla and Waymo and Audi, they're all using different models. It's not that they will all use this motion planning, but as we can see, we have Emcee and Rider and LiDAR, and we have car detection, pedestrian detection, and so on. This all gives a motion planning, an approach to decide how to and when to, like, accelerate, steer, or stop and move. So let's get into a picture. So as we can see, car detection, we can see there is a car. And you have pedestrian detection, like if the human is moving or if there is even a person or not in the road. And motion planning is making its own decision how all this data is helping it to make a decision. So basically, a car detection, what it does is it detects a multiple car on the road, and or if there are even a car or not on the road. And so you can see there are 2 different images which has 2 different cars, and it is detected. And you also can see that there is a pathway, and we can see there is just 1 car. So what car detection does is it finds out if there is a car or not, well, simply in the road. And we have pedestrian detection. It detects if there is a person walking or not on the road, similarly like a car detection. And it all gives this information to motion planning, and motion planning makes its decisions. Like as you can see in these 2 big pictures, one we can see the car is the front car is in the motion and is driving, and is giving a motion planning the thing that there is a car and you are not supposed to run it over or make a different turn. And in second picture we can see the car is in parking, and we can see there the red line, which shows that we can take a different turn. So these are the key steps for autonomous vehicle, but there are even more. This is just the beginning. So basically now we don't just have car detection and pedestrian detection or just image, LiDAR or radar. We also have GPS and map. We have lane detection, traffic light detection, obstacle detection, trajectory prediction, and this all helps in motion planning to make a decision how to drive, or when to stop, when to move, or when to take another turn or decisions and all. So this makes autonomous vehicle an autonomous vehicle, but this is just a simple step. It's not like the advanced one, or this is not a step like everyone is taking. So what is the use of AI in this particular autonomous vehicle is? So as you have already seen, like the different units of things that a vehicle must have, like car detection, pedestrian detection, and so on and on. And one way, this is just in one way to use is deep learning neural network, and the most common one is supervised learning classification model. So there are other methods too, but deep learning neural network is widely being used, and but it's not compulsory. Like all the other following companies are using the same models or same training data. So this model is like a brain of AI, and model parameter is the internal structure for decision making, and this requires. This gives an model parameter initial data, the requirement of detecting several objects falling under the category of well, supervised learning and classification, meaning AI is given this training data to classify objects. So initially we train with random internal structure data and compare the decision made in training data and input to find if it's making the same decision as human or not. And if this is making, if the AI is, if the decision is different, the AI actually what it does is it changes its own model structure and it changes its decision and it tries to imitate the human decision as much as possible. For example, let's say we are driving a car and we have there is a wall and we have to take a left turn. What the training model has is just that we have to reach from point A to point B, and it might not detect the different path at first. So what it does is maybe it gets crashed on the wall, but later the AI, what it gets is it trains itself and it decides that we should be actually taking the left turn. And so AI is more into imitating the decision made by a human. So so that's why it makes autonomous non-autonomous by taking this self-decision on its own. So let's see this video where you can see how the car is taking all this decision with the help of the map. It's taking the correct path and on the same lane and defining that this is the lane you have to walk, you have to move, and so on. You can also see even in the dark. So there is no object and it's still moving on the same lane, not making any errors. So this is this. What are the pros of autonomous vehicle? Well, it's believed that it will improve safety, visibility, fast traffic flow, higher efficiency, 24-hour availability, and lower environment impact, reduce driver stress, and so on and on, like reduce paid driving cost and more. So what about the cons is, the cons is while you're driving, it might have like hardware and software failure or some hacking or risks, including like maybe the accidents and all, and the increase in infrastructure cost and security and privacy and traffic problem and maybe reduced employment. So these are the cons of autonomous vehicle. So challenges with autonomous vehicle now is even more because we are always like the big companies or big giants are trying to reach to level 5 of autonomous. So we have like radar and lidar. They're widely used in vehicles. Like I have here mentioned 3 vehicles. One is blue, yellow, and green. So the blue is giving a signal with the help of radar and lidar. So what happens is even like 2 of those cars also might have like radar and lidar, and that might give a mixed signal to another car, and it might take a different decisions or even the decisions that are not correct for the road. It might cause an accident or it might give a false information. So also with the weather conditions, like if there is a heavy snow or lightning, or we might not be able to even see the lane, and the car or the autonomous car won't be able to detect if this is a correct path or not. So this is also one of the challenges for autonomous car. Similarly, we have like regulation and law, like some country might not be okay with this, or there might require to build a different type of tunnel or bridge for especially for just for autonomous car, or there are many things, but this has a very long way. But even like more countries are very much concerned on how to operate an autonomous car in a very safe way. So this is very very strict, as well as it's very challenging for countries to implement autonomous vehicles. And another one is accident liability. Like what if there is an accident, and who is going to take the liability or the accident cause? It might be a vehicle or the robot itself or the AI or the manufacturing or the road. So there won't be a liable source for accident. We might not be able to find the actual cause of the accidents in autonomous car. Well, there might be, but future has it. And another one is artificial and emotional one. As you can see, that people are walking on the pathway. So what autonomous vehicle might not be able to do is they might not be able to stop at the correct time, or will not be able to detect if there is a pedestrian or not, or if the deer is just running and won't be able to stop, then it might cause another accident. So there are a lot of decisions to make. So autonomous vehicle might not be able to take all this kind of risky decisions. So this is another challenge for autonomous vehicle. So, autonomous vehicle have both good and bad impact. So we're still not in this level 5. We're still in level 3. Various other big giants are trying to implement AI in many spaces. But for now, we are just hoping to have a flying car around and having a very long skyscraper where we can park our car in landscape buildings. So it's still in a testing and development phase. So many companies have taken their hands off from this autonomous vehicle, mentioning that it's not possible at all, while some are taking the action and saying that it is possible and we will make it happen. And so everything is going, and with this, I'd like to conclude this presentation. I hope you all had a very nice Magi Sangrati. I hope you all had a very good time learning about AI, and thank you so much, everyone. If you have any question, feel free to reach out to me in this email address, and thank you very much. Have a nice day. Happy Magi Sangrati.
Thank you, Ms. Kabita Lama, for such an insightful session. Now it's almost time for our last session for this event. You can find social links to join Nepal Cloud Professionals community and Nepal Power BI user group in the chat section. There has been much learning throughout the session. Now, without delay, last but not the least, I'd like to call upon Mr. Sushant Gautam for the next hands-on session on train and deploy a PyTorch model using the Azure Machine Learning Platform. Mr. Sushant Gautam is project manager at Analyst. In this session, you will learn to build and deploy your own trained vision model to a highly scalable endpoint using Azure Machine Learning. Let's welcome him.
Hello, am I audible? Can you hear me?
Yeah.
Yeah, cool. Okay. Can you see my screen? Yes. Okay. Yeah, just confirm me. Welcome to the last session. So, as you mentioned, so okay, let me. So this is the last session for this meetup, and the topic is train and deploy a PyTorch model using the Azure ML platform. So this should be a hands-on session that every one of you should be doing in your computer, and we should be syncing up. But as I learned that you don't have Azure access or due to some technical difficulty, I should be doing it on my computer, and you will follow. That is it, right? Pradeep Dai?
Yeah, sorry. Could you repeat, Sushant?
So my sound is audible, or there is some problem?
Yeah, it's all audible. It looks fine. You're actually sharing your entire screen rather than the PPT, I think, right?
Oh, sorry. Oh, this is the entire screen. I'm doing
yes.
screen.
Yeah. Okay. That's good. Thank you.
So yeah, I should be doing this in my computer, and the participant, they won't be doing in theirs, right?
No, they won't be doing. I mean, the reason is because we are unable to, due to time limitations. Actually, we are unable to provide Azure access and lab in the real time. When we have the Azure access, we'll send this to the participants.
Okay, cool. Okay, then yeah. Although this is yeah. Anything? Okay, yeah. Although this was a hands-on session, so I will be doing it, and I'll try my best to convey. So my name is Sushant Gautam, and like she mentioned, I manage AI projects. So I'm also a student. So I'm doing my masters in IOE. So here are the links to my social media profile. I have also shared this slide on the chat. You can get access to this slide. So the session, the goal of this session is it is mentioned in the topic that we are going to build and deploy our own trained vision model. So just for quick info, how many of you are familiar with like deep learning model and vision model? Does it sound familiar, or you can write some like plus if you are familiar, and minus if you are not familiar in the chat. So just I want to make sure that it's quite familiar with you. X. Oh yeah, there is minus. Okay, some more. Okay. So there are many plus. So okay, I'll try to explain what this is to. So okay, you cannot write both. Okay, that's cool. That's enough. So we saw some cool applications in NLP. So the chatbot that is from NLP domain. So language, that is natural language processing. And in the last session you saw about some supercars, right? So that is the application of computer vision, so automated driving. So in that there is the use of computer vision method. So that is the thing that we are going to address in this lab also. So we saw some cool applications on vision there. So those kind of model need to be trained and deployed for such application to work. So we'll see how we can do that. So there are many framework. Some I have already mentioned about PyTorch and TensorFlow, things like that. So we'll be using PyTorch here. So we won't go so deep into coding and everything. So I'll just try to show how easy it is to use Azure ML. So there is a platform called Azure ML. So we'll be using that. So we don't need to get into the jargon of coding and knowing about machine learning much. So another important thing is that we will there is a problem with this kind of model, and during the so while deploying this kind of model in production, so we get a lot of problem. So it is very difficult to scale these kind of things. So a normal website in say WordPress or other Drupal, so it can be scaled. There are so many ways to do that, but machine learning model, it's quite difficult. So Azure ML Pro, it gives some great ways to deploy our model to very scalable platform. So we will see that later on. So this is the overall goal. So before that, I also want to know that how many of you know about Azure ML? So can you just write something if you know plus and underscore or minus. So because this is very new thing for me, so I just learned about it yesterday. Azure ML. So have you ever explored that, or this is the first time you have heard about it? While you write something, I'll just show you. So this is the home page. So you can explore this. You can just Google it and come here. So you can see that there are so many features. So you can rapidly build train models, and so I said the scaling. So it has options for efficient ML ops and also like responsible solutions. So we saw some slides on that also. So this is a platform that we'll be using. So it's very efficient and innovative platform. So don't feel bad like if you have not been here before. So I came to this just yesterday. I have never used that before. So it's very easy to use. I learned this in around 2 hours, and I could present the same thing to you. So so for any machine learning project, there are lots of things to handle, just like choosing models and like collecting data sets and deploying it, training. So that is the most difficult part, training. So this platform gives integrated solution for enterprise grade service for machine learning. So this is quite quite efficient, and it's very easy to use. So we'll see that. So typical machine learning project. So if you have ever been involved in, then this will be very familiar. We first define the task. So what we are going to do. So either it is NLP or it is computer vision. So what kind of thing? What is the main objective that is defined? And we explore the data. We collect the data, and we train the model, and we deploy it. So the deployed model can be accessed with the REST APIs, or there can be other ways to access this. And after that, we use some ML ops to monitor how this model is performing, and we keep on going through this loop and improving the model and making it sure that it meets our need. So this is the generic ML ops pipeline. So that is it. So the main thing in machine learning project is training the model. So this is quite difficult. So I was just googling so I get these statistics. I don't know how they collected it, but 90% of machine learning project never make into production. So I think it's almost true, because there are lots of things in ML project. And there are lots of points of failure, so it's very difficult for them to reach production, so they die in the middle. So this Azure machine learning platform gives us ways so that we won't have to leave the project in the middle, and we can reach the production very easily. So within the time I have, I'll try to deploy a model and show you how you can access that in production. So we can do it very fast with this. So let me get back and check. Okay, AutoML. Sorry, I was saying Azure ML. Okay, so yeah, there are many people familiar with this, and also some not familiar. So anyways, like I already explained about Azure machine learning. So this is just a platform. And I'm sure that most of you know about this Azure portal. So let's have a survey on this also, because since this is about Azure portal. So how many of you have access to Azure portal? So is this the first time you are listening about this, or you might have used this before? Oh, great. Now I get a plus. Okay, now, yeah, I will link all these things up. So at least, yeah, I believe that almost all of you have this. So actually, like you should have Azure Pass to access this. So you would get it for free, but some technical difficulties like Pradeep sir mentioned. So in the future, like you will get that pass and you can just access this. So when you register with that pass, you will come to this homepage. This is the homepage of Microsoft Azure portal. So that's it. Just understand that you'll get to access this page. Then I'll just let you know how to proceed from here. Okay, great. So the first thing that we are going to do is like we are going to set up some cloud workspace since this Azure is like it's a cloud in itself. So we'll use this to set up a cloud workspace for our machine learning project, and we will learn how to manage the data. Since I mentioned in machine learning project, data is very important. So you need to like have data source, and like the project should access the data. So we'll see how Azure like gives us platform to manage our data and make it reusable. So after that, the hard part. So we will be training a PyTorch model. So if you have not heard about PyTorch before, no need to get scared, because like, yeah, it's very scary to learn it from scratch. But now it will be very easy from because we'll be using Azure machine learning platform, and we don't need to know anything about PyTorch. But I'll try to explain some basics. And another important thing is transfer learning. So although like this should not be like it was not actually part of this lab session to talk about transfer learning, but like I think it will be quite related to talk about this here. So I'll try to link it up with the problem that was discussed in previous sessions also. So the final thing, and this is quite familiar to all of us, API. So we will deploy the model so that it can be accessed through an API. So this is the final goal. So the final result will be quite understandable to all, because that will be REST API. So you can use a simple like Postman or whatever you use. Just you will get an API endpoint. So you can just give an image URL, and you get the result from that AI. So this is the goal of this lab. So this will be the output. So let's continue. So yeah, I mentioned about transfer learning. So I think like since this is quite related to deep learning, so I should be mentioning it. So I took this slide from the previous session. So from Kabita's slide. So she talked about training a model. So so she mentioned that we initialize a model with some random parameters and something like that. So I edited this a little to make it straightforward. So what happens in machine learning is that training a model it's quite costly. So I have even data here, how much it takes to train a model. This is, for example, the model I'm talking about is some ResNet. So we'll be training this model. This is computer vision model, and to train a model, so it takes a lot of dollars. So you can see here. So it takes 4 days to train a ResNet 164 model, and it will cost you around like 6,000 Nepali rupee, $54 almost. So it is very costly. So transfer learning comes to rescue. For such situation, we can use transfer learning. So so you can understand what is transfer learning from its name. So we transfer the learn model from the previous training. So let me, I have something related to that, some topics. Let's check that also. So let me. I'll share this link to this tutorial. You can see what is transfer learning there. So what we do in transfer learning is that, so there are multiple ways to use transfer learning, but here what we will do is, so we'll use, so we can get, this is a ResNet 18 architecture. So we can, so this is the model of it. So although you cannot understand this, so just try to follow me. So you give an image to this AI model, and it gives some output. So this model is customized to give 128 output. For example, you train this model to recognize type of animal. So you have 128 type of animal in the output. So you give an image. So the image goes through all these. So there are mathematical calculations here, convolution, and finally you get probability distribution for output here. So this is a Resonate 18 architecture. And the good thing is that you can get, so you need some model weight. So all these convolution layer in the middle, they have some weight. So you can get the model that are trained by other companies like big giant like Microsoft and Google. So you can get the value of this layer from them, and you can retrain this model for your purpose. So if you fully train this model from scratch, from random, then it will take a lot of time, it will take a lot of money and resources. But you can use the model that are trained by other people. You can just put the value here and just like return this last layer, and you can reuse it. So that is the transfer learning we'll be talking about. So like I mentioned, like only so there will be very few use cases where you train entire machine learning model from scratch with random initialization, like she mentioned here. So for special cases, only you do that. So generally, you can use the knowledge that the model that was trained on a large data set has. So the problem with this is that in normal ML project, we have very less data. So it is very difficult to get data for machine learning projects. For example, you train a machine learning model to recognize Nepali rupee. So you cannot get like 1 lakh image for each Nepali rupee to give this model for training. So that is the problem, because you can take only like 100 or 200 images, and with that also you can train the model using this approach. So this is what like transfer learning is all about. So what we do is that we take a pre-trained network. So this kind of network, like they are trained on very large data set by giants like Microsoft and Google. So for example, they train this image, this network on ImageNet data set. So the ImageNet has 1.2 million images with 1,000 plus categories, and we use those models and we can use it to retrain. So there are multiple methods of transfer learning. So one is with initialization weight instead of random weight. So she mentioned random here, random model. So what we do is we just copy their weight, or we use those as feature extractor. So we won't go into this part. So we just we'll use in this project, we'll use the weight from this connet is initialization. Instead of randomly initializing our network, we will use the net that we can get from the pre-trained model. So this is all about transfer learning. Now let's come to our lab part. So there are 4 parts. So the first part is we will set up Azure machine learning workspace. So here are 4 steps. So it is very straightforward. You can either use directly use AI UI here, or you can use code. This is the code. So here are codes. So it's in the slide also. You can just do. So I'll just try to like synchronize what we do in UI and what the code does. So the first code is like it is for just configuring the default workspace. And if you are familiar with like Azure, so you should know this. So this group is resource group. So the group I have used is PyTorch workshop. So this is a group. So and you can give any name to your workspace. For example, I can write Sushant afternoon. So this is just initialization. So if when you use this code, so you don't have to like write this in every code again and again. So this is just setting default workspace. So I'm connected to one of the cloud container in Azure. So I'll show you that also how that is done. So there is a dev container here. So if you want to do this from start, so you can. So these all resources are from this workshop. So I'll give that link here. So so when you get Azure access, so you can just follow this step, and you can set up the dev environment. It's quite straightforward. You just click this button, and it will take you to container setup. So you'll just fill this form, and let's see what will happen. We'll follow this one by one. Yeah, you can just write some resource. You can select some resource group. So so if you don't have, you can create. So I already have some resource group, so I'll just use this, and you can give some name, dev container. So this is you might understand what container is. It is kind of some remote computer, so that will be running on cloud. So you connect to this computer to run your code. So you just write this and you click on create. So when you do that, you will get a resource like this here, dev container. So this is just a containerized. So it is Ubuntu container. So you can access this container from VS Code or any SSS like platform. Okay, this is it. So you need this IP. So this is a public IP. You can use SSS to connect here. So you follow. So you follow these things. So this is very straightforward. So this is the IP I was talking about. So this is public IP. So you use that and you install Visual Studio Code. I think like you have it. So this is a Visual Studio Code, and you install this remote SSS extension. So so you go here and you search here, and you get this one. So it's already installed. You can just click here and install. If it is not, then after that. You connect to remote dev container, so it's very easy. So you just open this palette, so Control Shift P and type connect to host. Connect to host. So this will come. So you just click here and you use this. So you just type the. So this is just connecting with SSH. So you just type username at your IP. So username will be global AI. So this is common for all. You just type global AI at your IP, whatever it is, something like that, and you'll get to connect. So they will ask password. So it will ask password, and you'll get access to that. So let's see. So I'm connecting. Yes. So now. We are connected to one of the container in Azure. So I have already used this last night. So you can see some data, files here, but it will be all empty. So you just connect to this and you run all those all the thing in this container. So that was to be done as part of the hands-on coding part, but since you don't have access, you can just follow these things when you get access. So it's very easy. So just everything is here. You can see the picture and follow this. So finally, when you get access to this, you can just now continue from here. Azure Machine Learning Workshop. So this is the lab that we are doing it right now. So it should be like 3-hour lab, but so since we have only 1 hour, so we'll do it very fast. So just it's very detailedly documented, so you can just follow. Now we are in this part, create a resource group. Now since we have access to this portal, so there are many Azure services you can use from this portal. So the one we are interested in is this one, machine learning. So you can just see here and check all the list. Go to all service and machine learning. Yes. So this is one. So you go here and you create a new service. So I have already 2 service I created that before. So you can just create from here. So you just click on create and you fill the form. So it's quite you have to create many things if you do this. But if you do from command line, it's not difficult. If there is nothing, you can just click on create new and just fill this and continue. Then so you can get one of the listing here. You can this is the name. You can give anything you like. So I would do the same thing from code because it's quite easier from code. You don't have to fill this form. So this is AJ configure. Okay, let me copy this. Okay, let's see. Let's try it here. Nepal NCP lab. So you run this code in this SSH. Okay. So this is it does nothing. So it just configure default. You don't have to write. You don't have to mention this workspace and group every time. Otherwise, like you have to do something like this and what like g equals to this value every time. So if you set default, you don't have to do this. So now this is the main part. So this is the alternative of doing manually here. So just clicking on create. So this is the alternative. You write just this forward. So it does the magic. Okay. It might ask for authentication if you have not done before, so it is very easy. It will go to the browser and you just log in there. So yeah, it was accepted and it will take time. Just now you can see that it will be refresh here. It will take some time. You have to wait. Yeah, like I mentioned, like you need so many things for for a workspace. So account storage and like keychain and everything. So then those things are here in this form, like account storage, keyboard, application insight and everything. So this code will automatically create all those things. So app insight and everything. So workspace and like keychain and everything. So you'll get one listing here. So just now let's assume that like. Okay, let's wait for some time. Okay, this is done. Everything is done here. Now it will appear here. It will take time. Okay, just let's assume that this is one of the yeah, it's here now. NCP lab. So okay, you can use let's use that. It's already, it seems already. Yeah, already. So this is now this was this is Azure portal, and what I'm talking about is Azure machine learning portal. So that is quite different. So Azure machine learning is a service of Azure. So we create a service here and we have to use this service now to access the Azure machine learning portal. You just go here and you just select the service which you want to use and you will get some way to access that. So here is a studio, here is a button, Launch Studio. You click this and you go to Azure machine learning portal. So you can see the change in URL. So this is link of Azure machine learning portal. So you will get to that space. So you can just choose any one of so if you have multiple use case, you can just create many service here and choose any one. So for this we'll use this. So this is Azure Machine Learning Studio. So here are beautiful UI. You can just explore here. So the main thing for machine learning, like I mentioned, was a data set. So you can see, you can just create your data set here and store in Azure. And another thing is experiment, like training. So we can use this dashboard to create training as well. So this is like pipeline. This is model. So you can see what model you train. So you just this is the UI. So you can explore it yourself. So now let's follow the tutorial. Okay, this is ready. Now, since we have completed this one, and this is also done, and now compute cluster. So in machine learning, like training machine learning models are quite difficult. So like Azure gives like some way. So you can define a different cluster for training. So normally the container we are using this is just for common tasks, just for like doing just for hitting Azure commands. So for training you need to define another cluster. So it's very easy to like create a cluster from this UI as well. So you can check here, there is a compute like on this tab. So you can, so this is in the UI compute cluster. So you can see like scale your compute cluster into single to multi-node workload. So for training, what resource you need, you can just like allocate from here. So this is the thing. So you can use command. So so it's your choice. So you can even use this UI. So you just click on new and you just choose what kind of machine you like. So this is the location. So you want GPU, then click GPU. So virtual machine size. So you can choose what kind of GPU you want, Tesla K80 or M60, how many cores you like, and so it depends on your budget also. So the money like it takes almost like 200 rupees per hour, like 150 Nepali rupees per hour, like, so you can choose anyone. So this is enough for us. So the example I will be showing will be very like not more complicated. So you can choose anyone. So you can just continue and you can give it some name from UI. So I will give it from UI cluster, and you can choose how many nodes you need. So minimum 0, maximum 1. So it will automatically scale. You don't have to do anything. So let's leave it to 1. So let's leave other options as it is. So you just click create. So this is one way from UI. So it will take a lot of time because like it's quite it have to allocate a different like it has to allocate this machine for us. So it has to search for free resource and like it has to create some virtual machine there, so it will take some time. So before like while we are waiting for this, I will also use this command line to create here. So this is the same thing from command line. We use this command. So the same thing. So this is the size, and this is like how many instances we use. So you might have like seen this the same parameter in the UI I showed. So you can either use this command or you can use the UI. So this is the name, no, this is type and this is name, and the same thing what is happening anyway. So yeah, it is creating and it will take some time, and this also will take some time. So doing that, we just like continue here. So yeah, this is done, and this should be it will appear here. Yeah, both are ready now, GPU cluster and from UI cluster. So so like Azure have allocated this machine for us. Now this is ready for use for training. So we continue this. So we can see the list. So this is the same list we can see. So if you are like if you want to see in UI, then it is here. But if you don't want to go to UI, you can just hit this command and see it. Yeah, the two cluster. This is the same thing. So that is all done. So what we did was we created a resource group, we created a workspace, and we so this is Azure Machine Learning Workspace is kind of a service from Azure portal. So we created this, and finally we created a Azure Machine Learning cluster. This is for training. So this Azure Machine Learning cluster is with GPU, so very powerful GPU, and this is the first part. So this is setting up AML workspace. So this is done. We are all ready. Now let's see the slide. Second part. So second part is like quite straightforward. So since I mentioned earlier, so for machine learning project, the most important thing is data. So we download the data set and we upload to Azure Machine Learning Workspace. Since we are training this machine learning model in Azure Cloud, so we have to send the data to cloud also. Like it is quite obvious, right? So we do this. So there are multiple methods we do. So we can either use UI. So yeah, we can use this UI to create data set. You can just follow this. So and from local file you can just upload here if you want. So you can just type of data, what is file. These are images. So computer vision, we are training computer vision model. So this will be these are images. Our data is image. So we just upload it. We can upload folder. So you can just select where is your data and you click on upload and it will upload. So this is one way. So but as a programmer, like it's not like a good idea to use this UI for data upload. So you might be interested to like write code and do the same thing there. So let's follow this tutorial for that. Okay, so let's see what the data are. So this is the data. So for this lab, we'll use this data. So normally machine learning model, like we have two data set. One is for training and another is for validation. So the data set is split into two parts. Like it is like quite common thing in machine learning. So there are 10 class. So these data are related to Simpsons. So you can just see there are images of Simpson. So this is the data we have for training. So our goal is to train a model that can identify this Simpson. Which Simpson character is this? So I think you are quite familiar with this cartoon. So finally you will have a model that can like recognize the Simpson. So this is the goal. So this is the data we have. So the validation is also the split. It's quite similar to the data, the same thing. So the main data set is splitted into train and validation. So we could have done this in Azure like cloud also, but like we have the data set already splitted, so it's quite easier. So here are 10 classes. So we just in the final, so we'll just give one image, and the machine learning should be able to classify which of the symptom like was the input. So this is the goal. So so let's upload the data to Azure cloud. So I have the data in my computer, but I'll be using this SSS. So this is a cloud container in Azure. So we have to download this there. So continue. So the data is already here. The same data I have already uploaded. Just you can run this script and it will be uploaded. So it will unzip automatically. So you'll get a zip. You'll download a zip and it will like split automatically. So the final output you get will be like this: data, train, and validation. So it is the same one I showed in my computer. So it's all done. This part. So now the part I want to like focus is on is like we have to upload the data to like Azure Machine Learning Workspace. So we could upload it directly there, but I want to show it how to do it with code. So you just create a file called data.yml. So I think you are familiar with YML. So okay, if you are not familiar, also we can just do the documentation. Okay, YML, that is why. Okay, so this is just data serialization language. So you can see some format. So you just write it like this. So you can write some schema in this with this language. So you can just see it here. We'll just follow this. Yeah, it's already written. I have just copied this, and okay, we just copy again paste, same thing. So we are writing this schema to tell the Azure to like follow this. So this is the schema related to dataset. So we don't need to do anything. We just copy this, and this is the name of dataset we want to upload to this UI. So so if you do create dataset from here, so this is the name, right? So so this is the same thing. So from the code you have to like you can give the name with this part of the schema, so that you can version your data also. So data store is like what you so whatever the name you want to give to the data store, you can use this. So here also if you like do something and so it will ask. This is the data store. So you can this is the same thing like workspace blob store. So this is also a workspace blob store. So you can like if you want to give a different name, you can just give it here or here. So this is the same thing. So local path. So we have our data here. So just here. So we are just giving reference to this. So with this schema, we can tell Azure to like upload the data in our local directory to this Azure Machine Learning platform. So this is what we are doing. Okay, it will come here. So let's continue now. So this is the command. So AJ is Azure, ML is machine learning, data create using this schema. So this is quite straightforward. So you just copy this code. So the code tells Azure that we are using machine learning service and we are dealing with data. So we want to create data. So the thing we want to do is written in this schema. So this is what we want to say. So we just run this code here. Yeah, it is uploading the data. So this will happen all in cloud. So it is not in our local computer. So since we are connected to a container in Azure, so this is done very fast. It's all done. It's ready now. We check again here. So it should come here. It will take some time. Yeah, it's here. So you can just it will take some time to like it will do some small profiling on the data, and you can even see the picture from here also. Okay, number of file. Okay, let's see if we can. It's still processing. Yeah, you can see it. Just you can see all the images we uploaded. So these are just images for training. So you can preview some image here. Yeah, this is the same one, right? So you uploaded from this container to our machine learning studio. So you can visualize from this part. Now this part is done. Now you can use this command to see this table. You can see from UI, yeah, there is no problem. But if you don't want to go to UI, just hit this command. Oh, sorry. Okay. Yeah, this is the data set we have. So it is the same thing. Yes. Now this part is also done. Now what we did that we downloaded the data set on this Visual Studio Code. So we are connected to a cloud container. So that means we downloaded the data on cloud and then we unzipped it. So yeah, I didn't run this code, but like we can just run this code and like I did this yesterday night. So you can just try this when you do. And we created a dataset configuration file in YAML. So this is this file we created this that tells that to upload this upload the content in this data folder to this name in Microsoft Azure Machine Learning Studio, and we use CLI to create the dataset. Like that means this command, this one. So yeah, this is very straightforward. So either you can use UI or you can use code. So we did from both. So this part is also done. So any problem until now? So how many of you are still? So are you getting me, or like it's quite difficult to follow? Any suggestions?
It's going good actually.
Very good.
Yeah.
Yeah. I can understand because like since you don't have access to Azure portal, so it's very difficult for them to like it's just they have no option then like see me like moving here and there. So anyway, yeah. Now we are on like part 3. So this is about training the model. So so to train your model in Azure Machine Learning platform, so you have to do like so this is the flow. You download the training script. I mentioned that we will be using PyTorch. So this is you don't have to like be an expert in using PyTorch here. We just use the training script that is like that is available in the internet. So we create a job configuration. So we tell the Azure Machine Learning Studio that we have some training job, so we need to see how to create this, and we run the job. That is, we do the training and we monitor the output, and finally we check that our model has been registered. So this is the flow. So this is not like machine learning flow, but this is the flow of Azure Machine Learning Studio. So almost like the thing with training and all the course about PyTorch is in this script. So we'll just download it and use it. So we won't go into detail into ML, but because like that is that is a big jargon. So we'll just see how it is done in Azure Machine Learning Studio. So if you have your own script, you can use that. But like I'll use the script downloaded from internet. So I can explore the code for you if you like. But let's see what we can do. Yeah, so this is the code. This will just download the script. So you can see this script here. Okay, let's we run this code here. So it will create a train directory. So it has mentioned. So it will create a train directory and it will make a file train.py here. Okay, so this is the training file. So if you have your own machine learning project, you can use your .py file, Python file. So nothing to worry about. So so actually like this is this part of code. They have borrowed the code from like PyTorch tutorial. So I sent that tutorial. Everything is okay. Yeah. So yeah, I shared some link before, so you can check that. So this is it. Transfer learning for computer vision. So this is the code they have taken. So if you want to go into detail, you can check this thing. So so they load the data and they visualize some images. So this is the data set of Ant-in-B, but we are using Simpson 1. So this is the same thing. So we train the model. So all the codes are there. It explained very beautifully. So here are comment. You can just understand this, and we train and evaluate. So this is the same code that we are using, but the data set is different, and it has been modified to support Azure Machine Learning platform. So you can get this code from the tutorial if you like to see. So this is the thing. So we are not going into code in detail. So now since we have this training script, we have the data set. Now we want to create a train job using Azure Machine Learning Studio. Now for that also we need to create a schema. For the job we need to create a schema. So let's see that how it's done. Yeah, and there is no UI option for this part. So since like training machine learning is quite like they have to use code for that. So until now in Azure machine learning there is no way to do that manually. So there is no create option here. Oh, there is. Let's see. No, there is no. So you can just like open notebook, but there is no option to create this thing, this job here. You can just like there are other things, but you cannot create job from here. You have to use the code. So it's very straightforward. You just like create a file named job.yml and you submit to Azure Studio. You write your things here. So let's write here. This is it. So this is the schema for job. So you just copy. So it's available in like it's open in internet. You just copy this schema. So this is the schema description. So you don't need to worry about this. You just copy this. So you give the experiment name here. So you tell which you tell where the like local path for the code is. So it is inside this train directory. So you just say it's inside .train. So this is changing like a directory for code. So you give the code the Python. This is the Python code for training like command. So this is what you do to train this in your local computer. So you can just write the command here. So this is the environment you will be using for training. So you will be using PyTorch 1.7 and with Azure ML. So we want CUDA 11 GPU. So this is all jargon. So if you are new to like CUDA and GPU, so like it's quite, it will be lots of things for you. So I won't go into detail. Just this is the this is the common environment that you use to train ML. So this is the container. So you can get the list of this container from here also. So here are environments. So there are so many lists. Yes, these are the specification of computer that you want your machine learning model to be trained on. So this is it. So you can use different version of PyTorch, Ubuntu, and like GPU also. So TensorFlow also available. So you can just check this out. So for now we will be using whatever is here. So after you use this code, so after that, so this is the target cluster. So you remember this, we created this cluster. So you just write the name of cluster you want to train this model on, and the data. So it is the name of our data is Lego Simpson. So it is inside Azure ML Lego Simpson. So this is the standard format. This is the version. So we versioned our data set as 1. So this is 1. So this is the basic schema. So after this is done, you just run this code. So this is very straightforward. So AJ is Azure command machine learning job create with this file. So this is the thing. So you just go here and you just paste this. So it will submit the job to Azure machine learning platform. So this is called experiment. So it will come here when it is submitted. Yeah. So okay, it will take some time. Yes, it is here. So experiment name was Simpson classification. So when you uploaded this schema to Azure, when we gave this command, so this to Azure, so it created our experiment here. So you can see, so it is in queue. So it will take like 5 to 10 minutes for this to run, because like there are so many jobs going on from worldwide in this type of cluster in Azure Machine Learning Studio. So our job has to wait some time to get to this resource. So it will take some time. Okay, like we cannot wait for it to complete. So I'll just continue. So after the job is complete, so you can just see the model that it will save the model to so here is model. So when the job is complete, it will save the model here. I can show you from another. Okay, this one. Let's see from here now. The training is running on here. It is still in queue. So yeah, so this is the one I did yesterday. So you can just check here. Yeah, when that is done, so the code in that Python file, like it is written that the model will be dumped. So the model can run on ONNX framework or PyTorch. So it will dump like 2 models. So you can use either of them. So since we are following PyTorch, we'll use them. Let's not go into detail in what is the difference between these. So just we'll use the PyTorch PyTorch model that is dumped from the training. So this experiment will run here. So after like 15 minutes, it will be completed. So this is the completed one. So yeah, it will be completed, and you can see all the metrics. So this accuracy and loss. So loss is reducing after each step, and accuracy is increasing. So when it is completed, the model will be dumped here. So this is the thing you have to understand. So and that is all about this. And you can after this is done, like you can just use this command to check what kind of model you have. Let's see. Yeah, this is different since I have been using different workspace, so it is not showing. So when it complete, it will show. So it is still running. No, it is still in the queue, so it will take a lot of time. So that is the thing. Now we'll just continue, just assuming that it is done. So this will show that like the list of model like that is available. The same list is this one. So it will show that in this CLI. So that is the thing. So after like we validate that model has been registered, we can just move forward. This is it. So this is the final part of this lab. So in the final part, we just deploy the model. Okay, this one. So we locate the model. So that is very easy. So this is to locate the model, you go to the UI and you check this, or you run this command. So it will just show the same list. So this is the list. We locate the model and we configure the deployment, and we like deploy and test the endpoint. So this is the endpoint will be in REST. So you can use tool like Postman to check the REST API. So that is the thing. So let's continue to this part. So yeah, locating the model, we are in this same part. So we just located it, and the deploying is very easy. We just go to this part. Yeah. So for deployment, you choose this endpoint. So we started with dataset, we did training, and we are not using pipeline here. We just after training, the model will be dumped here. And after the model is there, you can deploy it, or you can just choose this and click on deploy from here. Okay, let's deploy it. So there are multiple options. So you can use to real-time endpoint, batch endpoint, or web service. So since REST API is web service, so this is the one we'll be using. So you can give a name. Okay. Professional. Okay, small. It should be all small. So NCP demo. And description, you can write anything. The compute type will be container, so we just write that container. So for when we deploy the model, so what will happen is like the input we give to the model will go through this pipeline. You remember this, right? Yes. So we give image, and the image will go through this network we trained, and it will give some output. So this is what happened. So to write all those workflow, we use a Python file. So in that Python file, it is written that what will happen like when the image comes here, and like it will give the right output. So we should have a file. So those files are here. So you can download from here. So this is it. So here are everything. Like when input is like you can see that this function will get input data, and it will return the result in this format: time, prediction, and score. So this is what this model do. So and there is another thing. So this is environment. So for this network to run, for this architecture to like run, we need a PyTorch environment. So this the thing that should be installed there, Python and all the pip dependencies that is in this file. So we need two things: this script and the environment for this to configure. So we'll just check it out here. So entry script. So we'll just load that file. So when we give model, so it goes through this file. So when so for that we need to also define like dependency, conda dependency. So these are two things we need to deploy the model. So Azure cloud instance and no authentication. We can also like we want to make it a public endpoint. So that is it. So advanced, there are so many options. So you can use. For now we won't use this. So we just click on deploy now. So we are on this part now. So sorry, this part. So we configure the deployment, and it is being deployed. So it successfully started, So deployment started, so you can just check the progress here in the endpoint. So it is it. So it will take a lot of time for this to work. So it also depends on the compute resources that is available on Machine Learning Studio. So it is in progress, so it will take some time. So I have another one ready one. So you will get the same like this in the end. So it is already deployed. You can see deployment state is healthy. So the final thing what you will get from this is this endpoint. So you can use this endpoint now to like query your image. So you send your image to this endpoint, so it will give the output of machine learning model. So that is what will be the final output. So, okay, let's see. Yeah, when you upload the image in this endpoint, so it will send the image to the script we stored, the Python script. So in the Python script, this model will be loaded. So your image will go through all these layers. The score of the weight of this model will be loaded from this one. So it is saved here. So this will be loaded, and you will get the final output in some JSON format. So that was in that code, right? So this will what happened. So when you use that endpoint, so it will go through this code and you will get the result. So this is what will happen in that endpoint. So, so let's check this. So it's still transitioning. It will take some time, 15 minutes. So it will be like this in the healthy state in the final one. So we'll just at final we have to use this endpoint. So this is all what's about. So let's use this endpoint now. So you might be familiar with this like Postman. So this is a public endpoint. So you paste you send a post request to this endpoint. So you say raw, you have to like send a raw post request. So in JSON format. So you just configure your Postman to this to use this raw JSON format. So you write your image. You write a JSON where there will be an image. So the value of the image is image URL. You can keep one image URL here. So let's check what this image is. Okay, this is like a Simpson. So I don't know what this is. So it is BART. So when you give this to model, you just send this request. So yeah, you get Bart Simpson and the score is 74%. So the model predicted that it is Bart Simpson by 74%. So let's check with other Simpson. So EMPS Simpson. So I don't know other name, but I will try a random one. Okay, this one. We have to Simpson. Okay, let's try father. Oh, this one. Okay, I just wanted a link. So okay, let's change this and let's see what will be the prediction. Yeah. Oh, something's wrong. Image. Okay, this is the image.
Sorry. Because I'm listening. The time say extra late asam हामीले हैन. कति टाइम कति मिनेट जति लिम अब हामी चाहिँ
Yeah, this is the final thing. So you just change your image and you can check this. So the machine learning will give output. Right? So almost we are in the end. So okay, I'll try to complete very fast.
Okay.
So like we completed this lab for also like this is almost in. So what we did was we started from like lab 1. So it was like we set up the workspace, we load the data, we train the model, and we finally could test the endpoint. So this is the thing like you can do with Azure Machine Learning Studio. So that is all about it. Yeah, I know like this lab should be of like 4 hours, but we did it very fast. So you can use the resources that I pointed to, and you can follow this one by one. So you can start from here, and when you get the Azure Pass, you like set up dev environment first, and you get access to this through VS Code, and you can just continue from here. And you'll at final you'll be able to deploy it, and you can get some endpoint like that and test. So this is all about it. So I think like it's all done from my side. So if you have any question, just you can contact me like LinkedIn or even Facebook. So that's all from me. Thank you for listening. Thank you for your time.
Okay, just to stick to role play on the quickly. Thank you so much, Susant, for your very interesting session. Actually, really loved your session personally, and hopefully a lot of other people in the call liked it. So thank you so much once again. And so basically, I want to give a vote of thanks to all our speakers. Anisha, Baidya from Dogma Group, Kabita, Lama from Dogma Group, and then Srishti from Kathmandu University. To you, Susant, Gautam, for your interesting session. To Eve Pardi from Avanade. So for all the sessions, I think it was pretty interesting, and I mean slightly off the time going definitely. However, it was worth it. Saturday, being a weekend, I think it was the best utilization of the time. So, I've added my email address on the chat, pradeep.kandel@nepalcloudpro.org. Please, if you are specifically looking for Azure Pass, I would like to request you to send a quick email to me so I can forward that to you. That's it. And before we close, is there anyone maybe who would like to speak a few words? Any one of you? कसैलाई केही भन्ने मन लागिरहेको छ भने चाहिँ please you can unmute yourself and speak up, else maybe we can close. Srishti, is there anything you would like to add? Or Kabita, Anisha, John, I can see John, Paul, other in the call. If you have any further any query or anything before we close. Suraj, Prakash, Prajwal. Yeah, Anisha, please go ahead.
Just a minute. Sorry. Hi all. I just wanted to add that the AI group at Dogma is pretty new, and we're also looking for people interested in and experts in the field to join our team. So if any one of you is interested in AI or also learning more about the team, please feel free to reach out to me. I'll leave my email at the chat in the chat as well.
Okay. So yeah, thank you so much once again. Thank you so much everyone for joining. And please, if you're not part of Nepal Cloud Professionals Facebook group or meetup group, meetup page, please do join them so you stay in sync with our upcoming meetups. We have really good lineup of upcoming meetups. I saw Simon from Swisap Corner joining this meetup, but he just left. Basically, we are planning to come up with Nepal Cloud Summit in April, and it's going to be huge. It's going to be in partnership with Swisap Corner. So basically, Swisap Corner has like I would call say 500,000 audience worldwide in terms of the developer ecosystem, and we will be partnering with them to run Cloud Summit, pretty much focused around Azure. However, again, it would have sessions around AI, ML, then IaaS, and PaaS. There's a lot of developer tools, and then the DevOps. So we'll try to cover a lot of these areas. So next month we are coming up with a global Power Platform Bootcamp next month. So again, that is going to be interesting because we don't have a really big community of Power Platform users, but then there are a few companies in Nepal who have resources working around the platform, including a Dogma Group, which has a lot of people working in this platform. So it's going to be interesting to also to those who would like to learn this platform and be part of this ecosystem moving forward. So with this, thank you so much for joining this meetup today, and hopefully we'll also come together for Global AI Bootcamp 2023. All right, with this, I officially announce the closing of today's meetup. Thank you so much, everyone. Have a good day. Bye-bye.
Thank you.
Thank you for the time.
Thank you. Bye-bye.